Okay, we are almost there. Two more questions. This one, let me shrink it down a little bit so I have some room to work, is with the, good, got right. Okay, so we're doing, we're going to get consumer surplus and producer surplus after we find the equilibrium point, place where they both the consumer surplus and producer, the price sort of where they're both where they both intersect is what it is. Equilibrium point is both, and there could be when that happens, there can be still some surplus and producer super. Both of them can get surplus at a particular point. So so that's basically what we got. We've got two. We've got the demand function. So d of x is a price in dollars. D of x is the price. So this is the price in dollars per unit that consumers are willing to pay for x units. Okay, so x is the number of units. That's the price we get, and s of x is the price. So the output is the price in dollars per unit that producers are willing to accept for x units. They won't sell it for anything less. So that's that. What I'm going to do is drop down, and this comes from our text. So for consumer surplus, we're talking this formula. We integrate the demand function, and then we subtract Q times P. What's Q times P? Well, that's Q would be the number of items and the price they'd be willing to pay at some set value. We're going to find out what those two are. So this is the expenditure, and this is a consumer surplus. The consumers, because you're able to offer it at a lower price, and these consumers who would have been early adopters actually pay a less price, so there's more money out in the economy. It's kind of a good thing to have happen. And then these consumers who have this surplus, we might go spend it on something else, help the economy. The other thing is it's the same at that particular quantity and price. At that intersection point, if we set the price there, then what happens is, because we look at the producer surplus, they were willing to sell it maybe for less early on, and then as they get more demand, the price goes up. The producer's also getting a surplus based on that by being able to offer a higher price for initial offering. So surplus from the producer, but notice it just subtracts differently. So here's the point where of interest could be the same. With consumer surplus, we integrate their demand and subtract off this QP, this bottom part, and with producers, the QP is sort of in a different place. We're taking that and subtracting off the actual costs, and then that gives them a surplus. Equilibrium point is just the intersection. So notice we've got the demand on the consumer side, the willingness of the producer to sell it. When those two things intersect, that's called our equilibrium point. And the X in this case that we're looking at, the number of units, that's our Q that we're going to use, and the price is the Y value, that's our P. Okay. So first we're going to do all of this graphically, just like they have. We will graph both functions, the demand and the supply side. Find their intersection. That gives us our QP. Then we come up and we can use these two formulas. We go from 0 to Q. That's the number of units we're going to produce. We integrate the various functions, and we either subtract off this rectangle, or we take our value and subtract it from. Okay, so just remember the two types of things. So it's just an integration, subtracting off Q times P. Again, I wouldn't expect there to be more than one question like this on the final. It's just a little bit involved. So first thing, we've got our functions. We're going to get their intersection point. That gives us our equilibrium point. So you see, you really need to have a graphing calculator. You just can't do this. Well, you could. You could just set them equal and manually. Since they're linear, you could do it. But we could also do it this way. 3000 minus 40x. That's one function. The other function, 300 plus 5x. You could actually do the integration here as well. So what we're doing is we're setting d of x equal to s of x. So you could do it manually. 3000 minus 40x equals 300 plus 5x. Solve for x and you'll get your intersection point. And then you plug it back into both of these, or either of them, you'll get the same y value. That's the idea of the equilibrium. So when we go to graph this, notice this starts, the first function starts at 3000, so I'm going to want my window, my y value, to be up there around 3000. Actually, I like to go a little bit above 3500. The x, we don't know. I'm going to make it, I don't know where these, and this is like 300 and going up. This is 3000 coming down. Okay, so we're setting the window size. And when we have these equal, we're just kind of guessing. I'm just going to go out to 100. Maybe that'll work. If not, I'll go out further. So then I hit my graph. There's one. There's the other. So we're fine. We can see it. And how do I know to set the window? Well, again, looking at y-intercepts, that helps with the y. And it's a guess on the x. I could have gone 10 and I would have seen I need to come out further and further. So we just get some experience as we go. But anyway, I've got my intersection point. So I go second, calc, and I want to find the intersect, 5. Enter, enter, enter. And there is my equilibrium point. It's where the two supply and demand are equal. Okay, so that's what goes in here. Remember, that's a quantity of 60 with a price of 600. That's whatever we're selling. It's pretty good stuff, huh? Okay, so remember, this is quantity, this is price. That's the ordered pair. So when we go, again, they don't provide the formulas for us, but to find consumer surplus deals with the demand function. So d of x dx, and then we subtract off q times p, because that's what we're getting is this kind of thing of the Riemann sums. We're getting this area from here. We're getting this little rectangle that is 60 by 600. Now, 600 is obviously higher, but because of the window size, we're going from 0 to 100 and 0 to 3,500. But it's this little rectangle that would be right here. Okay. So to do this, we do, what is dx? So we're going to integrate, and again, we go from 0 to q, right? That's the quantity. So we're going to go from 0 to 60. That's our value. 3000 minus 400 x dx, and then we do that, and then we subtract q times p. What is q times p? 60 times 600. Okay, so then we integrate. Let's just get this guy out of the way. 3000 becomes 3000x because we integrated it, x to the 0, right? Add 1 to the exponent, divide by 1. The second term becomes x squared, right? X to the 1 plus 1, that's x squared. We need to divide by the new exponent, and we still have this 40. So again, 40 divided by 2 is 20. So while we're at it, I don't like to keep rewriting, but we'll take that and divide. But I like to show it because if I don't, you'll see, where did that 20 come from? Well, it's 40 divided by 2. Now we know. So that's that. And we take it from 0 to 60 in 3.5 seconds, right? Subtract off the 60 times 600, P times Q. So the good news is that each of these has an X in there. So when we plug in the lower limit of 0, you'll see it happen. This becomes 0, right? 0, 0. So we don't subtract anything off. We just focus on the upper end of our boundary. So we get 3,000 times 60 minus 20 times 60 squared. And then we still have this part back here. This is all we have to calculate. And that will give us the surplus that's the consumer surplus. So let's see, 3 times 6 is 18, and we got 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. 60 squared, that's going to be 6 squared is 36, and then you've got 60 times 60, so you got 2 zeros there, and then you're going to another 0 here, so we're going to have, let's see, 3 zeros. 1, 2, 3, right? 1, 2, 3, and then 36 times 2 is going to give us 72. And then 60 times 600, 6 times 6 is 36, and then we get 1, 2, 3 zeros. And it's just a matter of doing the subtraction. So many zeros and everything. I'm just going to go. It's not that I couldn't do it, but sometimes, we want our mental energy to be saved, to be thinking through problems, getting them set up. And I'll tell you what, I find it helps not to do the simple calculations. It's just kind of like, okay, this is easier. Let my mind take a break. I just have to count the zeros and not worry about flipping some numbers like I do, minus, but concentrate enough that I get all the zeros right, I get all the signs right, and then let the machine take care of it for us. 72,000. So that's our surplus. So we're by selling it at this price, we're allowing an extra $72,000 to stay in the economy to the nearest cent. Well, yeah, we did. Okay, producer surplus. Now the producer is different. Let's go back to our graph. So the producer's graph, let's see which one. Let's go back. I think they are the S of X. So they're the second graph, which is going up, right? So they're this one. And their surplus is the top part. Because again, we take this bottom part. So this bottom part is their actual expenses. So their surplus is the top part. So what we got to do is we got to take the rectangle minus them. So the rectangle minus them. So Q of times P, Q times P, that's that rectangle. And then the surplus is, what we're going to do is subtract off the integral of this, which is the bottom half of this area. And again, we can come down to here, same thing. Their surplus is on top. So we take this rectangle and subtract off their actual costs. That's what we're doing. And if you can kind of visualize it, it makes it a lot easier to remember. And again, we're dealing with this function, S of X, the surplus, this supplier, I guess, think S for supplier. We go from 0 to Q dx. So let's put in our values. Our Q and P, since we're at the point of equilibrium, it's the same. 60 times 600. And then notice, so what we've done, let's see if I can do this. I'll draw it on here. Actually, let me do this. I know a lot of you probably just want to get the answer, but I want you to understand what the answer is giving us. So let me see if I can paste that. Yeah, paste it up here. Let's go like this. Let's take it out of there. Everything else is now in a good place. So let's go. Red is okay. So what we've got is this box here. This is our point Q. Over here, this is the P. Right? So this is 600. This is 60. So that forms a rectangle. And then what's happening is, what we're finding right now is this this area. It's not a good color to draw that. Let's go with blue. So we're finding this area here, which is the rectangle P times Q minus this here is the integral S of x. Okay. This line up here, let's do that in a different color. Let's go with purple. It's a good color. We'll go with black, actually. I think will show good. So we got this one. And this is our, so if we do this, we're getting, this is our, just this part. That's our consumer surplus. Everything underneath this part here comes from the integral dx. D of x dx is going from 0 to q, right? So that's our limit. So it would be everything down here, but we subtract off this box. So notice this S of x dx, that is the actual cost of producing. And when we sell at the equilibrium price, it's kind of cool because both the producer, the people who make the stuff, get a little bit more than they would have if they would have just done sort of market rate, from price, raising it as it went. And also the economy, the consumers get a little bit of surplus, well, actually a lot. So, but this picture shows us we were expecting a lot less than 72,000, right? This was 72,000. So this is going to be less. Okay. Maybe you just fast forwarded through that. That's fine. Or maybe you just thought about, oh, I could have fast forwarded through that. But anyway, the more you can see the picture, then you don't have to worry so much about these formulas. They'll come to you. S of x, what is our function? 300 plus 5x. Okay. dx. So we integrate and we multiply. So this, let's go ahead and multiply. 6 times 6 is 36, and there's 1, 2, 3 zeros. So see, we're going to be subtracting off of this. And we subtract, I'm going to do this, 300, integrate that, that's going to become 300x, right? X to the 0 plus 1, that's where we get that. The second term becomes x squared. We've got to divide by the new exponent, and then we get the 5 still there. Okay, and then we take that, we've got to evaluate it from 0 to 60. Now the 0, when we plug in 0, we get 0, so we don't have to worry about that bottom half of subtracting anything. It's versus subtracting 0, so that's why we just focus. We just plug in the 60, and that's going to give us our answer. Okay, and let's just see. So we get 36,000 minus 300 times 60 plus 5 times 60 squared over 2. And 3,600, 3 times 6 is 18, and 1, 2, 3 zeros. So we see already half of that's going to be gone, right? 36, yeah. Oh, careful, little crow. Sorry about that. See this plus? but there's this negative. That's a good thing I put these parentheses. It reminded me this negative actually has to distribute here. Otherwise, bad things are going to happen. Not really, but it's not going to work out right. There we go. Subtract. And then this one, 60 squared is what? 36 with 2 zeros. You divide that in half and then multiply by 5 is how I'm going to do it. Half of 36 is 18, right? Yeah, with 2 zeros. And then now we multiply that times 5. So we get, that's 40. That's, let's just do it this way. 0, 0, 40, carry the 4, 50 plus that's 90. So that's 9,000. So we subtract 9,000. And then I think that's going to be about 9,000, right? Because you subtract 18, that makes it 18. You subtract 9, that should make it about 9,000. We'll just do a quick calculator check just to be sure. But that's what it should be. Right, we just subtracting 3,600. 3,000. 36,000. Subtract 18,000. And then subtract 9,000. 9,000. Okay. And so that's our answer for up here is 9,000. All right. And we could do one check here because we have, and I'll just show you. If you add these together, the total surplus is what? 81,000. Watch this. I hope it works. I haven't tried it yet, so we'll see. Which one was on top? Well, this one obviously starting higher. So Y1's on top, Y2. If we subtract the 2, we should get the total surplus. The area, let's see, will that work? Yeah, because we're taking the upper, subtracting the lower. Remember this lower one, Y2, is actually the actual costs. We should get the total surplus, which will be about 81,000. Well, not about, it will be. So we do Y1 minus Y2. And I'm going to turn these off just so that they're out of the way. Maybe I should leave, yeah, we'll turn them off. I think it's be clear. So this is, we're getting the area under this curve should be the total surplus. And to calculate that, we go second, not second quit, we go second calc. We want to take 7, the integral. The lower limit is 0. Upper limit is 60. And watch, it'll give us this. It's supposed to be 81,000. Oh, it's so nice when this all works out. Okay, so we can't do this. Well, we got the formulas to get them individually, but if you just want to find the whole, this is all money that's now in the economy that by moving the price to the equilibrium price right away, this amount of money would stay in the economy. If we follow market and charge higher for the first few things and lower, as we go, actually the money gets used up differently. Nobody has a surplus. That's one of those things of economics. Doesn't seem to make sense. How can we start with this price? Well, it's again, instead of starting with this price, so you could see how the consumers have a lot more because they're buying more. Because if you start with the price up here, nobody's going to buy anything. So you got to come down a bit, and then people will buy things. And anyway, it moves things along quicker, and everybody is better off financially now. Okay, so that's it. I'm going to go to the next one.